Well, welcome people. Today I wish to discuss some core concepts of computer vision, precisely how to describe an image and what an image really looks like in a computer. For this, I'll be doing some schematics and some demonstrations, and we'll start off like, let's say we have an image. Um, to represent this image of a cat, we usually make use of visual screens or like visual monitors on the computer visual screen. But how do they look like actually in the form of data? Um, we can see how they look in the form of data. So in order to express this in data form, this all this needs to be pixelated in some fashion. That is, we'll form tiny bit of pixels of the input image and then translate it into a data form. And how would that be? Each of this would look something like a number which will be represented by some floating point values. Let's say it's 0.11. um, Now in order for computer to understand, this number needs to be processed. So this is a form of like representation. So let's say this is representation, and this representation now needs to go to a decoder which can actually decode it back to an image of a cat. So in a sense, the computer decoder needs to understand what these numbers represent and how would they finally make a cat. Now, what are the popular decoders we have? We have somewhat like decoders from OpenCV, which uses the image method, and we have Python inbuilt decoders as well. Moreover, we also have a very popular image visualization toolkit, which is like Matplotlib. So now we should talk more about what these numbers actually represent. So in order to make sense of anything, let's say we have a certain grid. So this forms a matrix. As of now, let's take it as 2D matrix because we want to represent something like an image in a 2D format. Usually what you've seen must be in this fashion. An image must have been represented in this fashion, that is batch size, channels, heights, and width, which is in itself a 4D tensor. What would this mean? This would mean in a particular batch, especially related to deep learning, how many images are there in the batch. This is just a number. The key features are the channel's heights and width. And in these two heights and widths are actually the number of pixels on the height side and the number of pixels on the width. As of now, what we can see, we can simply count them to be 1, 2, 3, 4, 5, and subsequently on the width side it should be again 1, 2, 3, 4, 5. So these two values represent nothing but physical characteristics or number of pixels. Now what about channel? This is one of the interesting parts in an image. What do channels actually represent? So in the case of black and white images, there will be just one channel, while in case of RBG kind of image, there will be 3 channels. So what essentially do these channels mean? Let's go back to our figure of a cat. When we see a cat, our visual perception or our eyes actually don't know how to process these numbers into an image. But what we see is signals. signals coming from the cat, or the rather the image of a cat, and we kind of process it in our own mind. I mean, our brains are also made up of neural networks, so it can process what a cat is in an image and fire neurons in our brain to activate and thus create a visual perception in our visual cortex. But in order to represent this in a computer, we don't need all this visual cortex and stuff like that. But essentially, we only need some features which can effectively represent a cat. These features, as I said, are these pixel values which we have on the figure. These would have pixel values somewhat like 0.9, between 0 to 2, between 0 to 255, and this would represent the intensity of the object at a particular pixel. Now let's break it down more further. So let's say we had a cat, something like this, and we also had the stencil of the pixels. Of course, I'm not drawing all the pixels. So in order to capture this aberration, how would the cat look in our current pixelated format? So let's say we associate this pixel with a particular value. And hence our current cat would look something like, or rather, and let's say all these pixels are empty. So only this, and this, and this pixel is basically filled. So our current cat would look something like this on any visual tool which I mentioned before, which are like either OpenCV, Python inbuilt, or Matplotlib. But in order to, but this nothing looks, but this looks nothing like a cat, right? So in order to define it more, we need more pixels, and henceforth this image would require more number of grids, that is, more number of pixels in the width side, as well as the more number of pixels in the height side. Okay, so I mean, I'm sure you must be observing it that if we have more condensed pixels, then what would happen? Let's just view this particular pixel out of thin air. So if we have so many pixels, then we'll have somewhat like which kind of captures this face, or the face of the cat. So it's just this pixel which is being overlaid out here. Now what about more number of channels? What would channel do? So in order to represent a picture in black and white format, we only need just one channel which can either be, so one channel, and it can either be black or white. That is, if it's 0, then it's black, and if it's 255, then it represents white. But what if we want to represent different colors as well? What would that mean? So that would mean we won't go with the black or white formation, but we would go with an RBG kind of format, where each channel would represent something. So let's say we have red, we have our blue, and we have our green channel. Each of the channel would represent pixel values as well as the color values, whether this particular cat's face is of which color. If it's just of red color, then in this particular region only the channels corresponding to the red values would fire. The rest of the blue and the green channel would be zero. Only this channel would have those numbers which we were talking about. Moreover, can there be any other way to represent a picture on the computer, rather to visualize a picture on the computer? Definitely there can be. That is, given an image, we can have like plenty of channels. We can attribute different things or different features of the image to different channels. That is, let's say this one only detects the forward strokes. That is, any edge at 45 degree. This channel only detects this edge. The other channel, the channel at the back, only detects edges at 180 minus 45 degrees, which is 135 degrees. Now this channel only detects the circles or the semicircles, let's say. So we can have n such channels which can detect n features. And remember, this space has to be closed. Now, how to represent it? Now we need our own decoder. Remember when I was talking about a representation, an image, the encoding, and the decoded image back. So this was the actual image which goes into the computer and it gets encoded into some pixel values, pixelated form. And then we need a decoder which is provided by either OpenCV, Python inbuilt, Matplotlib, or there are many others as well, which can decode this encoding back into an image. Similarly, if somehow we kind of store an image with these kind of features, then we would need a different kind of decoder which can decode this information back into an image and visualize it to us on the screen. So all we need is a decoder which is either trained with data or is rule based, which only needs rules. So what do you think the current decoders which decode the intensity of pixel values back to the image are? So this is my question to you. And how do you think you would train a database decoder, like which can have these features, n set of features, and decode it back? In a future video, I plan to record a coding session where I can show how n features can be represented back into a visual form of data or visual form of image. Moreover, in the next video, I would also talk about what convolutions do and how convolutional features are mapped to visual representations. You may have seen or you may have heard that the first few layers of convolution kind of detects the broad features, while the later layers kind of detects the agglomeration of those features, like faces and body, and faces of a cat, body of a cat, stuff like that, while the first few features would detect edges, eyes, and stuff like that. So think about it, and what is the relationship of those convolutional features with the features which I was talking about, the n features which can be decoded back into an image. Okay, see you guys. Thank you.